with this sort of increase in strength and decrease in weight, would that open up the possibilities of what composites could be used for in manufacturing? Traditionally, it's been used a lot for aerospace and a little bit in the automotive industry, but could that be expanded?
Oh yes, the beauty of it is that with a molding process, you can mold just about anything you want with carbon fiber. Most people, when they see carbon fiber, they see the zigzag weave, really cool look to carbon fiber. But it can also be incorporated into what's called a thermoplastic. You wouldn't necessarily know that it was carbon fiber you're looking at. It would look like a plastic piece, but you could actually have carbon fiber embedded in it with the foam core underneath. You could make virtually indestructible children's toys. Not that I would recommend doing that with this product, but automotive bumpers are a big potential market because you can reduce the weight, increase the gas mileage, and improve the safety of a traditional bumper. That's a pretty good win.
Absolutely. So what are the sort of applications could be used for this? Well, really what I'm getting at is, could this sort of manufacturing process be used as some sort of future in-space manufacturing?
Could you use this for in-space manufacturing? Yes. The beauty of it is it's a well-known product, and it's carbon fiber. We have lots of years of experience, and because we don't need air and we have basically a closed system, we could assemble molds and manufacture whatever you want in space. Okay, so you need chairs, mold a chair. You need to have a table, mold a table. It's very simple. The process is the secret sauce. It's not the materials, it's the process. How you actually put this all together is the real winner. So yeah, anything, you need a tripod, make a tripod. You need a telescope housing, make a telescope housing. It's very simple and easy to do. And because of thinner, lighter use of materials, you're not using as much to make the final product. So yeah, there's a lot of good reasons to be using this stuff.
Now tell us a little bit about XēneCorp's plans. Do they plan on being subcontractor to manufacture these materials for people, or they want to try to make this material available to as many people as possible?
The answer to both questions is yes. XēneCorp is really looking to manufacture as much of this. Of course, they would love to manufacture parts of this type for anybody, especially if you don't want to set up your own facilities. Where I come in is Viaduct International is looking to get licensing deals set in place. So you're a rocket manufacturer. You want to make wings and the seats in your vehicle. You want to make the console. You want to do it out of this material. You just license the product, and we ship you the components, and you handle the manufacturing. So anybody who wants to build, sign a license agreement. They're in business. We'll send them all the components. If they want to have someone manufacture it, just give XēneCorp a call, and we'll get you taken care of that way too.
Wow, very cool.
Yeah.
Well, why don't you go ahead and explain the process of how this is done a little more, and kind of show off what it is that you have here for an example of this sort of solid composites.
Okay. You have to forgive this piece. It's very, very small, but this gives you an idea of what we're working on. This is a carbon fiber thermoplast material. So it's basically a plastic that solidifies at a certain it liquefies at a certain temperature, and then when it cools, it solidifies to whatever shape it's in. Okay. In here, you can see the foam core. This is the solid part, and these start out as a very, very tiny bead that's filled with gas. When they're heated up to a certain temperature, which is just before this plastic starts to melt, they expand very rapidly, and they put pressures of up to 15 kilograms per cubic centimeter up against this outside part. So the mold would follow around the outside. This would just lay loosely inside the mold, and then when these expand, it literally squeezes it up against the metal part of the mold and holds its shape there until it cools and forms. And it's really simple. But because these are microbeads, it almost looks like toothpaste. You can add whatever you want to into the toothpaste. We can put some carbon fiber material in here and make this a super strong part. We could add some rubberization materials so it would take the vibration out, which is very good if you're using it in, say, a tennis racket, because when the ball is hit, instead of the vibration traveling down the handle into your hand, it's absorbed in the frame itself, which is pretty clever use of the technology. It's an amazing, amazing material. And we can also create these multiple channels inside here. This is actually two different, what we call bladders in here that make this up. And so there's a reinforcement line that's literally put in place simply because we have some of the foam on one side, some of the foam on the other, and when it inflates, boom, you end up with a piece with a solid ribbing in between it.